The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, and welcome to this webinar where we will focus on best practices on how to effectively use AI and predictive analytics to enhance your decision support. My name is Kenza. I'm the VP Sales and Marketing, and I'm very happy today to be presenting this webinar with Morten Svensson, our CTO. Morten has experience on using AI, predictive analytics, and digital twin technologies in well construction, and also from optimizing drilling plans to real-time optimization. Just a little housekeeping before we get started. This webinar will take about 30 minutes, including the Q&A session. And at any time, if you have any questions, you can type them on the question box you will find on the GoToWebinar panel, and we will answer them at the end of this session. So in this webinar, we will start first by explaining some of the main challenges we see today when it comes to the actual decision centers in the industry. And before moving forward, we will provide an overview of the e-drilling technology so you can understand how this has helped our customers to make better operational decisions. We will, of course, show also different examples based on the experiences we have with our customers. And for those who want to know more about the IT infrastructure and the setup required, it will also be covered before the Q&A session. So I will use in this webinar the word decision center, which refers commonly to real-time center for some of you, but also some of you may call it collaboration room or monitoring room or operational efficiency center, drilling management center, and so on. But actually, ultimately, regardless of how it's called, most of the time, share the same objectives. For example, drive further collaboration and risk mitigation between the rig and people in the office, or improve communication and provide expertise to help decision-making, performance, NPT reduction, and so on. And when these decision centers have been revealed to be a good process for all the different reasons I just mentioned, we believe that today we are at the end of the hype cycle. As you may know, the idea started with a small-scale war room many years ago, and it gradually scaled up with a larger well visualization and larger facilities monitoring more and more wells. But today, in many cases, it's all based on human intelligence, where these rooms and centers consist of advisors or experts looking at the data or squiggly lines and deriving conclusions based on their experience, which means there is a human factor element and uncertainties when taking decisions. In addition to that, this is not easy to detect issues beforehand, such as stack pipe or influx or packoffs. So this is why we have been helping our customers to move from their existing setup. You want to have your people work on higher value tasks than monitoring data and looking at a data screen. With computers and softwares monitoring you well and providing your people with intelligence, with symptoms, diagnostics, and advice, such as first actions and optimal parameters. And the objective is to enable them to provide better decision support. Today, we have a global experience with customers using the e-drilling software in North and South America, Europe, and Southeast Asia as well. And each one of them has, of course, a different approach with regards to the way of working and using the software. But the outcome is actually the same. Our technology has contributed to a radical improvement of quality and well-delivery decision-making. We will cover on the examples some of these approaches or models from the different experiences we have with our customers. But before that, I will let Morten give you a technical overview of our technology. So over to you, Morten.
Thank you. So to be able to deliver an advanced decision support system, we are depending on a strong and proven technology. And if we think of it, it all starts with the actual well. And so you know that can be described by many parameters. Formation properties, temperature gradients, pressure window, and then we add the drill string and BHA, drilling fluid properties, casing designs, and also the rig properties. Together with that, we also have the actions performed on the rig, or the real-time signals that's kind of showing the movement of the string, flow rates, and so on. All this information we use to create a digital twin of the well. And on top of that, we add analytical layer or artificial intelligence and machine learning to detect potential problems in the well. That can be like pack-offs, well control incidents, and so on. And we want to detect them as early as possible. On top of that, we also add more analytics like forecasting and what-if analysis to do optimization and be able to drill faster and more efficient. Yeah. So we got a lot of questions around from all different places about the artificial intelligence we do. And the way we do it is what's called the model-based reasoning. That means that we have a model that we kind of model what's actually happening in the well or what should happen in the well. And we compare that to the behavior or the observations from the actual well. That allows us to not only look for patterns, and you know patterns of different events may be different in different wells and with different equipment and so on. Then we are able to actually compare what's happening with what should have been happening. So just some examples of the diagnostics or what's actually coming out of our analytics, because this is what actually gives the value we want to use. And we have a big focus on the typical normal potential drilling events. This can be, of course, well-controlled things, detecting potential influxes and losses, also when it comes to search and swab, and also other things like stuck pipe and porehole cleaning and pack-offs and so on. And all these things, the system actually monitors all the time to make sure something really bad is not happening. So we would like to talk a bit about kind of the different models or the different ways we implement kind of this kind of software into the different operations. So we have given them some kind of names. So we have the kind of the first way, which we call the live well support model. And in this case, it could be either it runs a decision support software and interact with operational team. It could also be one of our partners, or it could also be some people in the organization that is doing this. That means that the result of this is that eDrilling or the people running it is then advising the operational team during the operation. The original operational team can focus on their normal tasks or the routine tasks, and we don't need to change very much on who is responsible for what. Then we have another way of doing is what we can call a mission control center, where you actually have a real-time center using this software to help the operation. In this case, we would have some assigned super users. The people in the center would have full software ownership and do regular communication with the provider, of course, but also doing the communication with the rig site to supporting them in their operations. As a result of this is actual numbers we got from one of our customers doing this. They own the application, they have bought the software license and use it in their real-time center. And they have seen that they have increased the drilling efficiency by 10%. And they have also reduced the complex situations or accidents by 30 to 40%, which is actually giving them a lot of value. Then we have a third approach, which we call the hidden model. And in this case, it's kind of a service provider that uses the decision support software in their normal service. Their focus will be to increase the quality of their own service. And the rig team may not even know that the decision support software is used at all. So the result of that is that it gives the service provider a better service delivery and can give a better service. And there could be many examples of this, but we have MPD companies using our software in their MPD control system to actually help them to do the MPD operation correctly. It could be a mudlogger company using our software to assist the mudlogger to perform better and to actually detect things earlier than he would do normally. And it could also be a normal data aggregation service which needs to add some more value in their daily work. And then we have the fourth example, which we finally call the all-inclusive model. That means that you have a decision support software that runs on the rig for focus on safety and optimization. You also have a real-time center. You have assigned super users to do configuration and monitoring. And you have the other engineers involved in operation using the software for the optimization. The result of this is that you have the whole operational team involved. They all use the same software, and they have the software helping them to alert them automatically when something is wrong. The benefit of all of them using it is that everybody understands what is going on, and there is no kind of issues of understanding why somebody takes a decision. Decisions are then founded on the support tool they get.
All right, thanks, Morten, for all these examples. So I believe it is important to remember and highlight these key takeaways. One is find the model that fits you and fits your work process. At the same time, you need to think differently and build on what you have. You can upgrade and change your thinking. For example, if you have one person monitoring one well, you can upgrade to have this one person covering 3-4 wells, for example, with our technology. And this is, again, not only about freeing some space in your company. We all know AI doesn't replace human intelligence, but here it's all about being proactive and helping humans take better decisions. Another critical point is to clearly define roles and responsibilities with respect to the operational communication, but also to have a full ownership of the software to make it an active part of the operation and brings value to you. That also includes ensuring all the data sources to run the software are also correct and updated all the time. So now moving to the IT infrastructure, some of you are probably wondering about it. So actually, some of our customers run it in their own data centers, but we also have other customers who run the software in the cloud, for example, in Amazon Web Service or Azure. And the solution we provide is based on Kubernetes, which allows easier and better scalability and maintenance. It is also a secure solution with an integration with the customer AD controller and a secure communication protocols between servers and clients. So we can now go ahead and take some time for questions. Just a reminder before that, make sure you type your questions into the question box you will find in your control panel.
Yeah, we can just start with the first question. Will the driller have notifications on upcoming hazards? The short answer is yes. If you do kind of proper deployment here, and actually the driller has the access, he will have a screen where all the information is available for him. That means that the risk register is imported and shows in his system, so he can see where he is located according to the associated risks. And at the same time, he will also get diagnostics for the analytics system that tells him if something is happening and helps him to take the decision of the first actions to perform.
I can take the second question. Does eDrilling have people in the US that can help with our operations? Yes, well, eDrilling has offices in Norway, Singapore, Indonesia, and US. And then at the same time, we actually also have a large global network of partner companies that can support both the deployment and the decision support system, but also deliver either a remote or an on-site support service.
Yeah.
Would you like to take the next question, Morten? How is the deployment done in a mature organization?
Yes. Our experience is that all organization, even if it's really mature, is that there's always room for improvements. But of course, in a mature organizations, there is a very clear roles and responsibilities, and everything is set up. And in the case of that, and if it's only kind of running for one operations, ad hoc or whatever, maybe the best solution would be to add an eDrilling engineer or an engineer from our partners to be the decision support service person into the operational team. That would kind of then have a trusted advisor within the team that has only focus on this, and all the others in the organizations can keep on with the focus they have from normal from before.
Thanks, Morten. I think the next question as well is for you. Does every field need different data set and different algorithm setup?
Yeah, that's a good question. So since we use the model-based reasoning, we of course we need to set up how we need to feed our mathematical models of what the well should be with all the kind of formation properties, BHAs, fluids, and so on. So that is a big difference. We also the rest of the data should be different, and the algorithms are the same. Some of the parameters might need to be tuned a bit based on the quality of the data that is available. We see when we compare our kind of modeling and compare that to the real-time data, we are depending on quality data. That said, we can do a lot of tuning on that to make it match. But normally, it's very little preparation from one well to another one.
Thank you, Morten. The next question is also interesting. Let's say there is a well kick. How quick the system will mitigate and prevent the incident? So for that, I remember a recent case for one of our customers where the system was able to detect the kick 2 hours before they actually had it.
Yeah.
Perhaps you can.
Yeah. And that has a bit of that we look at several different things here because we have the predictive thing where we look ahead of time and we can understand where we are according to the kind of pressure window or the window we have. And when we do forward-looking simulations, that we can see how we are according to those. But on the other side, we also see really early of events when something starts to occur. You could be the kind of the change of flowback that starts really early with very small amounts, And that has been for us a crucial thing to be able to actually close the well earlier enough to actually not having a big problem, or actually also just increasing the mud weight.
There is a question about the case of Wildcat wells and how is our model is built for the Wildcat wells.
Yeah, so good example. Of course, when you're doing a Wildcat well, there is some uncertainties of the data. And we use the data that's available. But as the operation starts, we tune us against the measurements. That allows us for actually being able to monitor and look for changes. That means that when we are comparing the prediction, the model with the real-time measurements, we can see changes, especially when it comes to hydraulic stuff, but also torque and drag related issues. Of course, there are some uncertainties maybe of the kind of the pressure window, and you could probably get an alarm for getting close to the pressure window without being actually close in real life. Also, you could actually have a narrow pressure window. But then we would detect the changes that happens in the well to handle that.
Yeah. Okay, and the following question, does the system keep feeding itself based on the findings on the well or the drilling process? So the system keeps feeding itself based on the real-time data from the well. This is a real-time process.
Yeah. Everything is kind of driven by the real-time data, but we also kind of learn a bit from what's happening. That means that it recognizes how, for example, the connection should look like with the flowback, and remembers that for the next time, so you can compare for changes.
Okay. We have a question about if it's using surface data. So some of it, yes.
Yeah. So the measurements we get is mostly surface data, but of course we also use the measurements like the PWD, pressure readings and stuff for calibration and also monitoring.
We often get this question about the calibration of the model.
Yeah, and yeah, but that's what we kind of do. We need to use some of the downhole readings to do calibration, but we are not depending on having them all the time, because most of the changes that's happening downhole will also affect the surface measurements. So for calibration, it's important, and it's helpful in the kind of the monitoring itself, but traditionally most of the kind of the events that we have detected is based on the surface data.
We have a question about, I will read the question if I got it right. So mostly e-drilling will have more on drilling plan than the e-drilling execution. Actually, what we have covered today is about the drilling execution. We do have other products that can cover the drilling plan. And when we talk about helping the real-time decision, as we did today in this webinar, it's all about drilling execution, and this is all based on the digital twin we have.
Yeah.
Okay. The next question is regarding building predictive model. Does it take a lot of time to build, for example, swap and search model?
No. So the time to actually do the work is not that complex. But when it comes to doing proper swap and search modeling using a dynamic model, it's time consuming kind of doing all calculations. But we do two things there. We do search and swap modeling upfront for the operations, but we also do real-time swap and search. That means that as the drill string is moving, the system is calculating this swap and the search and swap pressure, and then we use that to monitor against the limitations of the well. So it basically says you can move faster or you should slow down, basically.
All right.
Yeah, we have one. Can you use offset well information in your analytics? Good questions. We have had kind of historically, eitherlink had a focus on real-time modeling and real-time visualization. And the offset well information is basically information that we provide for the users. So it's in the system and it's visible, and you can see along the 3D visualization of the well the information about the offset wells, but it's not used in the analytics as of today.
All right. The next question is about the IT system. It's saying getting access to new IT system is always a slow process in our company. Do we need to involve IT department to get access?
Oh, yeah, very good questions. Yeah, we very often when we go to new customers, the IT department is usually involved at some level. But using our system may not need to be that complex, because the requirements that we have when it comes to the different things is not that hard. For example, if the real-time data source is from a ModelBased company and that is located in a cloud environment, we could get the data directly from them. And the software itself could run in a cloud environment, and where we would give access to the users to log on to use the web application. Then we actually would not need to involve the IT department at all. But normally we see that we should always include them to make sure, just to verify that it is a secure solution and it's not kind of going against the requirements that the old company has.
Okay, I believe with the time we have, we'll take one more question. The question says, when both office and rig site is using the system, are they working on separate system? So I can answer this one. The answer is no, they're working in that same system. Actually, all the real-time calculations, they are done on a server that is connected to the real-time data, which could be either with XML or WITS or OPC. And the client applications or web applications are used to visualize or do the forecasting simulation. So that means all the involved people in the operation are either they are at the rig or in the office. They both have access to the same calculations and diagnostics. So with that, we will conclude this webinar. And before, I would like just to say a few words. It's now time to move from people looking at screens and advising to have a digital advisory system. Thanks very much for joining this webinar today. We really appreciate you being here. And if you have any further questions, please don't hesitate to send me an email. We will also be sending the link to this recorded session to all the attendees. Thanks again, and we will see you next time.
Thank you. Bye.